Our next presenter is David Simmons. David Simmons is a senior engineer on the Texas Optimization Program and Response Team, TOPRT. He received his Bachelor of Science and Master of Science degrees in Civil Engineering from the University of Texas at Austin. David worked for an environmental consulting firm in Dallas, held engineering positions with the cities of McKinney and Taylor, and worked for a civil engineering consulting firm in the Austin area prior to taking a position at the TCEQ in 2013. He provides technical assistance to public water systems and TCEQ regional offices and conducts on-site evaluations of surface water treatment plants and distribution systems. Please welcome David Simmons.
All right, well, thank you. So what we're going to talk about today is really a guidance manual that we put together for systems that use chloramines and need to do a free chlorine conversion. The guidance manual, I've got some copies up here on the front. If you want to grab one before you leave, great. I think we even have some more over in the TA room if you want to have your own copy. But basically, I'm going to be following the guidance manual. What we've seen at different water systems is that they can do free chlorine conversions successfully and not so successfully. And we've tried to assemble all the successful strategies into that guidance document. It's called RG231. You can also download copies off of our website. Just go to the main TCEQ website and type in RG-631, and you can get a copy of that. What do I want to convey today? Just these items, basically. Some Texas water systems use chloramines to maintain residuals and meet disinfection byproduct regulations. Nitrification is something that can happen whenever you're using chloramines, and it can cause a loss of residual in your distribution system. And then, of course, today, big topic, nitrification can be stopped with a temporary conversion to free chlorine, which you may refer to as a free chlorine burn. So any PWS that is using chloramines can have nitrification in its distribution system. So this could apply to any of those systems. So why don't we at the TCEQ call it a burn? Well, for really two reasons. Conversion is more accurate. We're not actually burning anything, and it doesn't sound so positive to your customers to tell them that you're burning their water. So if you don't like free chlorine conversion, I've heard people say like free chlorine refresh, something like that, but just trying to get away from the term burn. So what is nitrification? Disclaimer here, nitrification chemistry and biology are complicated. An understanding of how to identify nitrification as opposed to other causes of low disinfectant residual is assumed here, but we're going to focus on the actual free chlorine conversion once you've determined that a nitrification event is happening. During nitrification, you have bacteria in your distribution system. Our distribution systems are not sterile by any means. They're definitely bacteria, and for the most part, they're not harmful to us. And the particular nitrifying bacteria we're talking about, they're not harmful to, for us to drink them. However, if they multiply and get out of control, it can exert a demand on your disinfectant. And then, of course, total chlorine and monochloramine residuals drop. When you have low disinfectant residual, that can cause, regrowth of bacteria, go through, and the nitrifying bacteria are coliform bacteria, so you can get coliform positive results. You can get potential illness, not from the nitrifying bacteria, but because of low residual, other things might survive in the distribution system. And then, of course, TCEQ comes with the violation hammer. So how do you stop nitrification? As I mentioned before, there will always be some amount of nitrification occurring in a chloraminated distribution system. Most of the time, you should be able to control and limit and control it with actions that are less severe than a free chlorine conversion. But if stopping it completely for a short time is the goal, the source of food for the bacteria, ammonia, must be removed. So we're not killing the bacteria directly with the free chlorine, because they live in biofilms and can survive a while. We're really trying to starve them by taking away their food source. So what are some pros of doing a free chlorine conversion? It's the only way to starve the bacteria. Otherwise, the bacteria can keep blooming or growing because they have food, ammonia. It's also important to realize that starving bacteria takes some time. Just a rule of thumb that we encourage PWSs to use is, give all points in your distribution system at least 2 weeks of exposure to free chlorine in order to have it successful. So that means 2 weeks at the farthest part of your distribution system as well. And it's important to remember that ammonia can't be present to any measurable amount if you truly have free chlorine. There's lots of ways you can get false free chlorine, and we'll talk about some of that later. So if the analysis that you're doing is clear, and we'll talk about how to do the analysis, that there is free chlorine present, as I said, there can't be any measurable ammonia. However, when you run your ammonia test, you may still get close to a zero number, let's say like 0.02, 0.05, some low number. When you have free chlorine, you just have to assume that low number is a false positive, and which can happen. So kind of a pro and a con. The free chlorine conversion only works on nitrification. Nitrification isn't the only thing that can cause low residuals, and we have other presentations and training to help you detect, if this is a problem from treatment failure, maybe increased demand in your raw water source, you have cross connections or unstable chloramines. If you have any of those issues, a free chlorine conversion is not the solution. So a con is it does take you and your staff more time to do a free chlorine conversion correctly. You need to do some work ahead of time to determine the required chlorine dose or coordinate with your supplier. You have to make sure all your valves and fire hydrants where you're flushing are all working. The actual flushing process that we'll go into in more detail does require more labor from your staff than would be normal. And then you have a bunch more monitoring both at the start and at the end. So another con is you might get potential odor calls. If you don't flush the free chlorine through the system really fast, there may be some areas that have unstable chloramines that smell bad, dichloramine and trichloramine. And here's kind of a figure to illustrate what I'm talking about. Let's assume that you're bringing the free chlorine in from the left side and you're flushing out the monochloramine. There's always going to be a zone in there between the two where you have dichloramine and trichloramine. It's just the chemistry forces it. You don't have a distinct break between free chlorine and monochloramine. And it's the same when you go in the reverse direction. You will have dichloramine and trichloramine that can be stinky. So it's really important to make the time spent in this transition zone as short as possible, just to avoid some of those complaints. Again, when you convert from normally sending out chloramines to free chlorine, I mean there's a different smell to the water and a different taste. Your customers may decide to complain about it. So it's a good idea before you start the conversion to try to set their expectations. Let them know what you're doing, and we'll get into more detail about that. You can also have color issues. This is particularly at PWSs that have iron and manganese issues, and they decide that they don't want to flush regularly because it stirs up the sediment, so they're just building up sediments in the distribution system. That practice of not flushing because of the color can actually promote nitrification. The nitrifying bacteria can live in those sediments. So the distribution system will have a better chance of resisting nitrification after the conversion if it is thoroughly scoured and cleaned. So, we highly recommend, cleaning the sediments out before, telling your customers, hey, we're going to have color as we do this, so that they're not surprised. So, are your booster chlorination units sized to breakpoint the chloraminated water they treat? So let's say you're a purchase system, you're buying chloraminated water from somebody, and you've got a booster station. If you don't have a booster station, obviously no, you can't breakpoint chlorinate the water. But have you ever tried to actually breakpoint chlorinate the water coming from your supplier? It's often the case that the booster stations are not designed with enough capacity to conduct a free chlorine conversion. There's just too much monochloramine and ammonia in your source water and just not enough capacity in your chlorine injection, because for normal purposes, you don't need that much injection capacity. But if you're trying to breakpoint chlorinate, it's very often you'll find that your booster station doesn't have the capacity. Now, one thing we do provide in the guidance manual at the end is help on determining whether your existing chlorine injection system has enough capacity to do a free chlorine conversion. And if it doesn't, how much more do you need? And then you go talk to your engineer and submit plans to TCQ if that's your goal. All right, so let's talk about planning for the free chlorine conversion. It's more than just turning off the ammonia feed. For these items like that are in bold and blue, like source, you need a source of free chlorine water. It can be your plant or the upstream system. And then, of course, you need to take into consideration what kind of system are you? Are you treating raw water, injecting chlorine and ammonia? Are you, a purchased water system and you don't have any treatment? I mean, things will be different for both of those situations. So you need to have a schedule and plan to flush the free chlorine through the system quickly and efficiently. And that means coming up with a sequence of the flushing, dropping tank levels. It's really important your flushing and dropping the tank levels will help the conversion go faster. Okay, and I'll talk more about that later. And then you're going to be doing this monitoring, particularly at the very beginning and at the end, to make sure, hey, we've got free chlorine now at certain places in the distribution system, and on the back end, making sure you've actually got monochloramine. You need to have a communication plan. If you are treating raw water with free chlorine and free ammonia, that's probably the easiest situation. You can just turn off the ammonia. If you're boosting pre-treated water with free chlorine and free ammonia, ideally you just turn off the ammonia and turn up the free chlorine to breakpoint chlorinate your supplier's water. As I mentioned before, that you may not have that capacity. And unfortunately, if you're a purchased water system and you have no chlorine feed system yourself, your only option is to work with your supplier to schedule the conversion and actually ask them to do a free chlorine conversion so that the water you're receiving has free chlorine. Now, it's easier said than done in some cases. What's the amount of free chlorine you need? The dose has to be high enough to overcome any ammonia, monochloramine, and free chlorine demand in the treated water. You've got to do some calculations, and you may find your chlorine injection system is too small. And as I mentioned, you can get some help from the guidance manual. But I guess the real point I'm trying to make is recognize the limitations of your existing chlorine feed equipment. All right, so talking more about the flush sequence, you want to flush the free chlorine from the entry point, meaning the point where you're going to be pushing the free chlorine out to the distribution system, and then don't go to the end of the system and start flushing. You want to flush at intermediate locations to pull that free chlorine through the system. And I will go into more detail about how that procedure looks. But it's really important not to start the free chlorine conversion without having discussed this with all your staff and have a plan. Don't try to do it in the field. In order for the flush sequence to work, your valves have to be working. You need to go out and fix any valves or fire hydrants that you need to do the conversion before you start the conversion. Here's an illustration of why you don't want to flush at the farthest end of your distribution system first when you're putting free chlorine in. What happens is this figure represents your distribution system with different branches, and each branch has got customers on it of different sorts. If you start flushing at the end first, you can get in these areas where you're not flushing hard. You're going to get a little bit of the free chlorine going in here, and that's going to interact with the monochloramine. In these closer branches, you're more likely to get the odor complaints. So basically, don't do this. That is not the way to do it. The way you do want to do it is flush from the source to the closest area first, and then go on, next farther place. And then finally, you flush at the ends of the distribution system. So I mentioned before tank levels are an important consideration for free chlorine conversion. And it's really important to decrease the amount of water in the tanks if you can, because, tanks full of monochloramine, you start getting free chlorine in there, the free chlorine is going to react with the monochloramine and it's going to kill your residual. So you want that conversion to go over as quickly as possible. And if you're a large system, you might consider cycling the elevated tanks that are closest, or ground storage tanks, whatever, that are closest to the source, and do other tanks in series. But again, that would probably only happen in a really big system. So to illustrate what I'm talking about, when I'm saying decrease tank levels before the conversion, it makes it easier to switch chemicals. Keep in mind that that'll make your conversion go slower, and it will also cost you more because you're going to have to put in more chemical, free chlorine, to get to react and overcome that monochloramine. So it's going to cost you more too if you do that. This is an example of showing how water, for example, free chlorine mixes into existing water in a tank. So just pretend these are water tanks and you've got free chlorine is full of monochloramine and free chlorine's coming in. Notice that over time, the top part of the tank, still remains monochloramine, and the bottom starts the conversion much faster. If you had a smaller volume, instead of the full tank, if you had the smaller volume, it's just clear, that conversion would go faster. How do you tell where free chlorine is? You have to do that with monitoring. I want to make the point that it's easy to get false free chlorine readings when monochloramine is present. Monochloramine interferes with our typical DPD method for free chlorine. And that's why you need to measure all four parameters here: total chlorine, free chlorine, monochloramine, and free ammonia. And you want to do that at each of your flush points. Then when you are sure that your flush point has free chlorine, because you see that the total chlorine value is pretty much the same as the free chlorine value, and your free ammonia is close to zero. As I mentioned before, you can get a little bit of a false positive on that free ammonia test, so don't expect you're going to get 0.00 on your free ammonia test. One thing I want to mention, though, is we have seen source waters, particularly surface water, that after the water goes through the breakpoint chlorination, there's still some other stuff that the total chlorine test is picking up that is not free chlorine. So you're not going to, like I said, not necessarily always going to get exactly total chlorine equals free chlorine, but if you can get it up to, free chlorine is 85% of the total chlorine, and free ammonia is about zero, you can be pretty sure you've got free chlorine going. So the communication plan, coming back to that, you need some internal communication, so make sure your managers know what is happening, and you're talking to everybody who's going to be working out in the distribution system to make this happen. And then you need to have an external communication plan, and always when you're doing a free chlorine conversion, TCQ should be one of your groups that you reach out to for external communication. The real reason you want to do that is during a free chlorine conversion, your disinfection byproduct levels, trihalomethanes, haloacetic acids, they're going to go out the roof. And so you really don't want TCQ collecting a DBP sample in the middle of a free chlorine conversion, because it's just gonna shoot your locational running annual average way up. But we may be able to delay the DBP monitoring until after the conversion, but you got to let us know it's happening so that we can make that happen. You also need to talk to your chemical suppliers and your wholesale customers, make sure that they know what's going to be going on. For one, you're going to need more chlorine than normal during this, so just need to be set up with your supplier. Another part of the communication plan that we highly recommend is that you let your retail customers know what's going on, and that you're trying to help them have clean water, and also set their expectations. Setting their expectations will just decrease the number of complaints you get during the process. How long will it take to flush free chlorine through your entire distribution system, including the tanks? Now, I don't know. I don't know your system. You know your system. So you probably have a pretty good idea at, if we're pumping in this flow rate, and we're flushing, we think we'll be able to get free chlorine through the distribution system, in so much time. To that amount of time that you determine, add that to the time it takes to do the conversion. You want to add that time at the beginning and at the end, and make sure then you've got at least 2 weeks between the beginning and the end, like I said, so you're exposing all the points in the distribution system to free chlorine for at least 2 weeks. That'll give you an idea of, how long your free chlorine conversion needs to last. All right, I'm going to kind of reiterate everything we just talked about through a series of diagrams of a water system. So in this one, this is a made-up system, Smallville. They've got their source coming in here at the bottom left. They've got some tanks here at the entry point into the distribution system. The pipes in the distribution system are shown in blue. Thicker lines mean they're bigger water lines. The pressure plane boundary, just keep in mind that particularly if you're a city, your service area may not just be your city limits. You may have customers outside the city limits. Your pressure plane boundaries extends to wherever you have customers. In this case, this system is small and just has one pressure plane. We show the tanks. What is not shown on here, that this diagram might be something you get out of your nitrification action plan, or your monitoring plan. What it doesn't have is where the valves are. Fire hydrants and valves you're going to need to open and close to do this. You need to take your map and add those items to it. I mean, if you want to print the map and do it by hand, great. But you need to show, where all the flush points are going to be. So before the conversion, you're going to check your flushing strategy. Start near the plant and then work your way out to the far reaches of the distribution system. Checking that the valves are working and, all your operators understand the sequence that you're going to go through. Have a plan, of how low you can drop your tank levels, and then calculate the needed dose of free chlorine. One thing with the operators is make sure they understand, what tests they need to run. Until you've, at the beginning of the conversion and at the end of the conversion, like I said, run all 4 parameters: total chlorine, free chlorine, monochloramine, and free ammonia. And once you're sure you've got free chlorine, you can just monitor free chlorine at that point for the rest of the conversion until you change it back to monochloramine. All right, so as I mentioned, add these flush valves, fire hydrants, whatever they are, to your map and identify them. Now, in this case, you can see that they're numbered like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is not the sequence that you would want to flush in. You might flush 1 and 9 first, and then 6, 7, and 8 down here. Second, maybe 3 and 4 third, and then finally do 2 and 5. That would be, kind of a logical way to do the flushing order. So when you're starting your conversion, first thing you're going to do is lower the tank levels, and then if this is a case where you can just turn off the ammonia feed, you just need to make sure you're injecting enough free chlorine to overcome any free ammonia, monochloramine, and free chlorine demand that's coming in the water, whether you're purchasing it or raw water. Because when you're operating with chloramines, you may not be satisfying the chlorine demand like you would be with free chlorine. Now you're converting to free chlorine, and there could be some demand left in the water that was just, wasn't touched by the monochloramine. Then you want to flush your free chlorine through the system, as we mentioned, in sequence. What I'm showing here is like at the very beginning of the conversion, monochloramine is green, free chlorine is pink, so you're just starting to get a little bit of free chlorine coming into the system. The yellow in between is that area that I talked about where you've got unstable chloramines, dichloramine and trichloramine. And then as you flush, you get through sequentially through the system until you get it to the end. And I'm just reiterating, I know I've said this before, but you're going to monitor total chlorine, monochloramine, free ammonia, and free chlorine until the free chlorine is about equal to total chlorine, and free ammonia and monochloramine are about 0. And then you can just start monitoring free chlorine until you get the monochloramine flushed back. The end of this conversion, you're going to do the same thing that you did, except now you're going to be putting in monochloramine and flushing out the free chlorine, but it should be the same sequence that you used at the beginning. All right, when you're ending the conversion, like I said, just do the same sequential process. It includes, at the end, you need to lower your tank levels again, because you don't want monochloramine in the water coming in reacting with the free chlorine. I mean, you want to limit it as much as you can. Repeat the monitoring at the flushing points, all 4 parameters, until you're certain you've got monochloramine. And then it's really important, if you haven't done one of these before, write down the lessons learned for next time so it goes a little bit easier. And it's always a good idea at the end of the conversion to inform us that you're done. What if free chlorine conversion is not enough for your system? If you're a system that has recurring issues with nitrification and the free chlorine conversion isn't enough to fix the problem, you may need some other long-term solutions. Those are kind of out of the scope of this talk. If you are finding free chlorine conversions not working, you probably need to reach out to your engineer and talk about some of these other examples of what you might have as long-term actions. You might have to loop mains to eliminate stagnant areas. You might need to add tank mixers or modify your tank inlets and outlets. You might adjust where your disinfection is going on, and there could be other things that would help you with that. So just a reminder, starting the bacteria takes time. You need to expose all the areas in your distribution system to free chlorine for more than just a few days. The TCEQ is reluctant to allow free chlorine conversions go longer than 30 days. The reason for that is we have this concept in the regulations about normal operating conditions. We can allow you to have high DBPs for a short period of time that doesn't represent normal operating conditions and reschedule the DBP sampling around those abnormal conditions. But for our purposes, the maximum allowable length of an abnormal operating condition during a year is generally 30 days. So bottom line, just make sure you're pulling the free chlorine through the system as quickly as possible so you get the most benefit out of your free chlorine conversion. Our financial, managerial, and technical assistance providers can help you on site. These are some of the things that they could help you with: tank cycling, valve sequencing, maybe even customer communication. And then, just take-home message, reiteration, your nitrification is always a potential if you have a chloraminated system. You can stop nitrification with a temporary conversion to free chlorine, but you need to do it right. You need to plan ahead, et cetera, et cetera. If you want to notify us of your conversion, you can just send an email to dbp@tcq.texas.gov. That's our DBP compliance folks.
You mentioned that the DBPs will go up when the free chlorine happens. Why is that? Is that like?
It's maybe not so much a problem with groundwater, although some groundwaters have total organic carbon in them. They have natural organic matter. Most don't. For surface water, if your source is surface water, there's always going to be organic carbon in there for the free chlorine to react with to make the DBPs. So those things don't go away when you treat with chloramines. They're still there, they're just not reacting with the monochloramine. So it remains there and can react with the free chlorine to make the DBPs. Good question, thank you. All right, not seeing any other questions, I think I'm done.